Hello everyone, welcome to the first problem-solving session. In this session, we will solve one example making use of the if condition. Just for the sake of doing some examples, we have taken one exercise where we ask the user to provide three angles of the triangle. So basically it will be three numbers determining the length of each side of the triangle, and our duty is to determine whether the triangle is equilateral, meaning that all its sides are equal to one another, is isosceles, meaning that only two of them are equal to one another, and scalene, if none of the sides is equal to one another. So all these are different. And as a simplified approach, I will consider that for the isosceles case, the base is oriented on this side. So we will have side A and side B, or side 1 and side 2, whatever you wish to call it, and the base. So if it is of isosceles type, we are sure that the orientation of the base is this one. So let's ask to the user three numbers, and base equals to, we have to cast the input to an integer, enter base. Let's give a new line, and side A and side B. So we have taken three numbers in input. Enter base, enter side A and side B. So what makes the triangle equilateral, isosceles, or scalene? If side A and side B are equal to one another, it can be either equilateral or isosceles. Then, if this condition is true, we have to check whether one of the sides, it doesn't matter if it is A or B, is equal as well to the base. If it is, then the triangle is equilateral. If it is not, then it is isosceles. So if side A equals to side B, we are under two possibilities, equilateral or isosceles. And how we determine which of the two? Then we need to have a further condition. If side A, or we might compare side B, it's the same, equals to base, then print a message: the triangle is equilateral. Else, because if it is not, then the only option is print the triangle is isosceles. Else, if these are side A and side B are not equal to one another, the only option is them to be scalene triangle. This is under the condition that we have the orientation of the triangle as shown in the figure. Let's print. The other option is that the triangle is scalene. Let's try it. Okay, enter base. Let's suppose base is 6. Enter side A, 6, side B, 6. The triangle is equilateral. Okay, let's write another example. The base is 7, side A is 6, side B is 6, is isosceles. And let's try a third option, 7, 8, 9, and the triangle is Cali. And it seems to work correctly. But the assumption that the orientation of the triangle is as shown in the figure is a little bit limiting. So in general, what we know is that we have 3 numbers. Each of these numbers represent the length of the side. So we don't know exactly whether the orientation is exactly as shown in the figure. So in the second scenario, all sides are of equal orientation to us. So there is no specific certainty, or we are not sure that the base is represented at the bottom. So to us, side A, side B, side C are of equal importance and orientation. Then, okay, under such condition, we have to revise a little bit the solution that we have implemented previously. In the first case, what does it mean for a triangle to be equilateral? Mean that side A is equal to side B, and side B or side A is equal to side C. It's irrelevant if we take A and B, A or B, to compare it with C. So if side A is equal to side B and side, let's say side B is equal to side C, then we know that the triangle is equilateral. We cannot implement as before the branching. If the side A and side B are equal, then we might have the first and the second case, because as we do not have the certainty of the orientation, we cannot say that the side A and side B are the ones with the orientation on the top. Though we have to check all possible conditions and situations. So in order to evaluate whether all 3 sides are equal to one another, we can write side A equals to side B and B to C. Or A to C is exactly the same, because if A is equal to B and A is equal to C, obviously, and B is equal to C as well. Okay. Aleph. What does it mean for a triangle to be isosceles? Only two of the sides are equal to one another. But the question is, which one? So A and B, or B and C, or C and A. So we have to evaluate all 3 possibilities. So if side A equals to side B and side A is different from side C, this is one option in order to say that the triangle, okay, I have it here already, is isosceles. But it is not the only option, because in another case, we might have that A is equal to C but different to B, or B is equal to C but different to A. It's all about how we identify the angles. But we have 3 possible options. So this is the first, but another is that side A is equal to side C, and side A is different from side B. So two of them should be equal to one another and different to the third. We have several and or these we have to group, pay attention to group the specific condition. So this is one condition that makes it true. If it is true, then I don't need to consider the others. I have found A and B that are equal to one another and different to C. Or the second scenario is that A and C are equal to one another and different to B. Or the third scenario, I'm just copying it and then changing the letters. Or now B and C is missing and A different from C. This is either shot. Else, the only remaining option is for this triangle to be scalene, mean none of the former two are true, so it is not equilateral because not all the sides are equal to one another. It is not isosceles because I didn't find a triple where two of them are equal to one another and the third is different. So the only option is for the triangle to be scalene. Let's try the solution, whether it works or not. Let's say 6, 6, 6. Okay, is equilateral. 8, 7, 8 is isosceles. Okay, and just giving some 3 random numbers which are different from one another, and it tells me that the triangle is scalene. So all the sides are different from one another. We have to pose a question once we get some input from the user. We are getting an input, 3 numbers. But are we sure that these 3 numbers do really form a triangle? Because suppose that I enter 1, 2, and 4. So let me use this just to design. So 1, 4, 2. These 3 segments cannot form, in any case, a triangle. So this triple is not a triangle at all. So before we check whether, which type of triangle it is, we need to make sure that it is really a triangle. So this triple, because we are getting an input just 3 numbers. First of all, we have to check whether this triple makes sense. Otherwise, this is not a triangle at all, in order to say then whether it is isosceles or equilateral or scalene. So this is not a triangle at all. But how we need to do it? So how we can check whether a tuple of 3 numbers like 3, 4, and 8. So this is not a triangle. It doesn't represent a triangle. The evaluation, so what we need to check is whether one of the sides is greater or equal to the sum of the other 2. So suppose this is A, this is B, this is C. So C is greater than 3 plus 4, meaning that these 3 numbers do not form a triangle. But in case I don't know the sequence of the numbers, it might happen that I call it this B, this A, this C. or this B, this I call it C, this I call it A. I'm just getting an input 3 numbers. I don't know the order in which they are entered by the user. They might have 3, 4, 8, but the user might enter 4, 8, 3, or 8, 4, 3. So there is no rule. I have just 3 numbers. And I need to check carefully whether these 3 numbers they form really a triangle or not. So what I have to do before I do any check of the type of the triangle, first of all, I need to check whether it is a triangle at all. So is the triple, or do the triple form a triangle? Do the triple form a triangle? It's a question mark. Okay, let's check it. If side A is greater or equal to side B plus side C, this is an option where one of the 3 options where the triangle is, so the triple, sorry, is not a triangle. Again, here we have 3 cases, or so we have to consider the 3 possible combination of the data that are input. So A compared to B and C, B compared to C and A, and C compared to A and B. So if any of these 2 combination is true, mean that one of the sides is greater than the sum of the other 2. Mean that this is not a triangle at all. And we print a message. This triple do not form a triangle at all. So sorry, I cannot proceed by checking the type of the triangle because it is not a triangle. But we have some code here, some instructions here that are supposed to continue with further check. In case it is not a triangle, either we can say else. So we, by the way, revise as well some nested conditions. So if it is not a triangle, else it is. Then if it is, I check whether it is equilateral, isosceles, or scalene. Okay, let's make a test. Let's say 8, 3, and 4. As a triple is not a triangle. And obviously, it doesn't consider at all this part of the code. Another options in order to interrupt the execution is to raise an exception with a message. Instead of printing this message, we can raise the exception, and the exception interrupts the execution of our program. So in case, let's say 3, 5, and 9, I will have an exception raised saying that this triple is not a triangle, and even though I don't have an else condition, it will not execute whatever comes next in line of instructions. So there is no, it makes no sense to continue further evaluation considering that this triple doesn't represent a triangle at all. So this is just the first example of how to use if condition along with nested condition. And what we usually do normally while programming is to evaluate whether the input of the user is correct, either from the syntax, either from the semantic. Because instead of providing some numbers, the user by mistake can provide letters. Or if I expect natural numbers, the user can enter some float numbers. So always when we write a program, make sure of the quality of the data that are input by the user. Never take for granted that they are correct or they represent correctly what they meant to. So these three numbers, are natural numbers, but in this case, they do not represent a triangle. So there is make no sense to do any further evaluation. So that's all for this first exercise.